With default route propagation. So OSPF also support propagation of your default route. So in the earlier example, we have R2, which is the autonomous system boundary router. It connects to the internet. Okay, so normally the connection to the internet will have a default route. So any packet that the router do not know how to route, normally we will send it to the internet, which is your default gateway. So you have an IP route 000000000, and you will be send it to 209.165.200.226. So your default route is configured on R2. So we can propagate this default route to the other routers so that we don't have to manually configure the default route on the other routers. So in order to do that, we run the default route command on the router that is connected to the internet. Then we run the default information origin command. Okay, that will tell R2 to propagate the default route to the other routers. So we go to the router OSPF end and then run default information origin. So to verify that your default route is propagated, okay, first we'll go to the R2, okay, where we configure the default route, do a show IP route. You can see that the default route is configured correctly. Okay, then we go to the other routers. For example, here we go to R1, we do a show IP route. We can see that R1 also have a default route, okay, but it was not configured statically. It was configured, okay, using default information origin via OSPF. So this was an external route received by R1, okay, and this is a default route that was received by R1 and it was sent by R2 using the default information origin command. Okay, next let's look at the hello and date interval. Okay, OSPF have this hello and date interval, and this interval must match, the interval timing must match between the two neighbors. Otherwise, they will not form neighbor adjacency. Okay, so the hello and date interval are configurable on the per interface basis, meaning a router with two interfaces, okay, each interface can have different hello and date interval. So it's configurable on the per interface basis. A typical example is, let's say this router is connected to another router using Ethernet and using serial cable to another router. So obviously serial interface is slower, so we will expect a longer hello and date interval. Compared to Ethernet, which is faster, we will expect a shorter hello and date interval. So we can configure them on a per interface basis. Important thing is that the hello and date interval between these two interfaces must be the same, and the hello and date interval between these two interfaces across a serial link must be the same. Then they can form neighbors. So to verify your currently configured interval, do a show IP OSPF interface. You can see the hello interval and the date interval over here. Okay, and to see that it's able to form neighbors, you can do a show IP OSPF neighbors. Okay, then you can see the date timer. Okay, you'll be able to see the date timer here. It's a countdown timer. So once the timer is set to 0, then it will assume that this neighbor is dead. Okay. So how do you configure the hello and date interval? You can leave it as a default value, but if you don't like the default value, you can change it at the interface. You can run the command IP OSPF hello interval and then the timing in seconds. Okay, so you can set 5 seconds for hello and date timer is 20 seconds. So once you change at one side, the other side you must change. Otherwise, the neighbor will be assumed to be go down because their hello and date interval does not match. So at the other end, once you change it to match the neighbor, then the OSPF neighbor will go up again. Okay, so if you want to reset it back to the default, just run the no IP OSPF hello interval and no IP OSPF date interval. At the interface command, it will reset back to the default value. Okay, in the last part, we'll look at some of the troubleshooting technique for single area OSPF. OSPF is a very popular routing protocol, especially in large enterprise network. Hence, the ability to troubleshoot problems, especially relating to the exchange of routing protocol in OSPF, is one of the most important essential skills. So, one of the common problems that OSPF face is they do not form adjacency between the neighbors and they are not exchanging routing packets. They are not exchanging the link state advertisement packet. So when your neighbors do not form, it could be that the interface are not in the same IP network. Okay, it could be that the IP address that you set on the two routers that are trying to form neighbors, the IP address are not in the same network. Or we also look at the hello and date interval. They do not match. You need to match the hello and date interval so that they can form neighbors. Okay. Or you set the interface to be passive, resulting in it not sending a hello packet out. Or your configuration is wrong. You have a missing or incorrect OSPF network command. Okay. Or you didn't set your authentication correctly. The password is set wrongly. Okay. So you must make sure all your interface are configured correctly. Okay, the address is set in the correct network and it must be up and running. Then your router will form adjacency with each other. So in order to troubleshoot OSPF, it's important to know that in order to form neighbors, the router actually went into different OSPF states. So there are 1, 2, 3, 4, 5, 6, 7 possible states that the router could be in. Okay, so in order to form neighbor, they must be in either a two-way state or a full state. Okay, if you remember, two-way state is between two DR others. Okay, they do not form full neighbor, but they are still aware of each other's presence, or the full state. Okay, so if your routers, if you go in and check your routers, they are not in these two states for a prolonged period of time, that means there's difficulty in them trying to form neighbors. So all states are transitory, so routers should not remain in those states, except in the two-way state or full state for extended period of time. Okay, here are some common OSPF troubleshooting commands. Okay, first, show IP protocol. This allows you to show you some of the key configuration parameters like the process ID, router ID, the network commands that you have run to advertise the network, the passive interface, and the neighbors, the router IDs of the neighbors, and also the administrative distance. Okay, show IP OSPF neighbors will allow you to show the neighbors that you have managed to form adjacency with. So R1 have two neighbors, 2.2.2.2 and 3.3.3.3. They are in full neighbor states. Okay, so other commands like show IP OSPF interface. Okay, will show you the OSPF version 2 interface configuration that have been configured on the interface, like the hello and the date timer. Okay, show IP OSPF, you can see the process ID and router ID, similar to show IP protocol. Show IP route will show you the route, and if you do a show IP route OSPF, will show you the OSPF route in the routing table. And if you want to reset the OSPF process, okay, you can run this clear IP OSPF process ID. Okay, so if your process ID is 10, so clear IP OSPF 10. Okay, then this will use to reset the neighbor adjacency. Okay, so this will help you to reset the process and then help you to reset the neighbor adjacency. Remember, this will also result in a re-election if you clear the process on the DR or the VDR. So this will restart the DR and VDR election. Okay. OSPF problem is normally related to neighbor adjacency, missing route, or the OSPF choose the wrong path, choose the longer path instead of shortest path. Okay, so these are the commands that you can use to troubleshoot problems relating to this. So if you have missing neighbors or the neighbor table is not correct, use this command, show IP OSPF neighbor, show IP interface brief, or show IP OSPF interface to help you to troubleshoot. If the routing table is not correct, missing routes, you can do a show IP protocol or show IP route to help you troubleshoot. Or if the traffic did not take the desired path, you can again use show IP route or show IP OSPF interface to help you to troubleshoot. Okay, if all of them are correct, it means that your network is functioning. So if you are running IPv6 using OSPF version 3, so all you need to do is replace all these IP command with IPv6 command, okay, to help you to troubleshoot your IPv6 OSPF network. Okay, so when you have neighbor issue, you can check your routing table using a show IP route command. Check your interface is active, is all up and running using a show IP interface command. Okay, check your OSPF active interface, the interface that is participating in OSPF using a show IP OSPF interface command, and check your OSPF setting using a show IP protocol command to see your settings. Okay, so in this case, for example, my passive interface is set to be G00 and CO00. It happens that CO000 is connected to a OSPF router. That's why we are not forming neighbors with it. Okay, so remember, check your passive interface to make sure that the passive interface is not set wrongly. Okay. For routing table issues, okay, we can run the show IP route command, show IP protocol commands, okay, to see your routing table is it correct, okay, and make sure that your OSPF setting is correct. Okay, finally, for multi-area OSPF troubleshooting skills, so in order to be able to troubleshoot multi-area OSPF, you should be able to understand how the OSPF process is used to distribute, store, and select routing information, how the OSPF information flow within the area and between areas. This will cover it in the multi-area OSPF chapter, and also use the same the iOS commands that we learned previously to gather and interpret the information. Okay, remember that OSPF, they actually store routing information in 4 main database or data structure. Okay, the first one is called the interface database. It will contain all the active OSPF interface that is currently participating in OSPF, or your active OSPF interface. So all your type 1 link set advertisement, okay, will be advertised, okay, with each of the active interface. Okay, you also have a neighbor table, okay, to find, okay, the router will maintain a neighbor table to find who are these OSPF neighbor. Okay, you have the link state database. Okay, remember the link state database is the entire topology. It's a full topology of your network, okay, where the router will calculate the shortest path, and the shortest path will be sent to the routing table. Okay, the shortest path will be sent to the routing table for each of the remote network. So that's all for this chapter on OSPF tuning and troubleshooting.